Okay, so today's class will be more about this Arima and Sarima. So let me just pull out my PPT, and if my screen starts swinging, just let me know. Okay, so we'll discuss this Arima and Sarima. So it's more about this time series model. Okay, Arima and Sarima. So uh, just to give you a context, this Arima and Sarima, it's a basic time series model, and we'll see how you can model it, because in the study class I have spoken about this Prophet and LSTM also, because it's a deep learning model. So I will be talking about this deep learning model as well today. And before that, I'm just trying to build a few concepts, and then you can apply this Arima, Saraima, Arma model, because these are the part of this moving average. Okay, so the way we have done it, for example, in previous classes, so we have something called the sales and the months, the number of sales in some months. Let's say there are 12 months, and the number of cells corresponding to each and every month is there in your data set. Okay, so how through this moving average, at least you can forecast the next month the number of cells. Okay, so I mean, this there comes a concept of moving average. You are trying to move the average over the months. Okay, that is the simple way. So whenever there is something called MA, so it's more about moving average. Okay, and the same concept of moving average is are given some kind of you can say the analysis, or some more sophisticated mathematical modeling is added on moving average only. If you see this ARMA, ARMA, autoregressive moving average, and then autoregressive integrated moving average, then this MAX, so X can change, but the logic behind this this moving average will stay the same, right? So if you remember only the moving average concept, you can easily catch autoregressive and every single thing, even the integrated one. Okay, and there is also some examples of US GDP and inflation, and it's one of the classical example that how this GDP and inflations are interrelated. So once your inflation is high, so also GDP sometimes grows and sometimes gets lowered. So GDP and inflation is somehow negatively correlated. Okay, so there is a also few you can say charts that each and every country displays based on this inflation versus GDP, and we'll try to build some of the time series model out of this Arema. Okay, I'll see and try to see the explanations of it, because the important is that once your model is generating the response, it's very important to understand the result first, because the result which are coming out of any model must be you must be able to explain it. So I'll show you in LSTM and Prophet that where you can apply these two models, because these are the part of a deep learning model and you must understand that. Okay, so coming to this Arima. Okay, so it's a statistical model and for time series analysis. So whenever if someone asks you in an interview that give me 3 4 5 or maybe more than 5 this time series modeling, if you can remember that, because in interview they do not ask you to write the entire code, Python code, but they just want to understand that whether you are familiar with this kind of the modeling or not. So Arima, moving average, this exponential smoothing, Saraima, LSTM property, you must remember that so that people can understand that you know that these modelings are applied in time series forecasting. Okay. So there is a one term here on the screen that is something called auto-regressive. Okay. So I just want to bring attention here. What is auto-regressive? Okay. So for example, you all people use this chat GPT, right? So chat GPT works on the concept of auto-regressive. So for example, if you are asking, I am going home, okay? So to the chat GPT and give me the next sentence. So what they typically does is based on your current, text, they check what is the previous context to it, and based on this current, your prompt, they check what all are the probable words or sentence possible if I am writing I am going home. So they give you the all the combinations of I am going home with this, the auto regressive. So auto regressive is predicting the next sequence based on your previous sequence. That is auto regressive. Okay, just remember that. If someone asks you the example of auto regressive, just give this chat GPT example that whenever you give any prompt, based on this prompt, they predict the next sequence. That is auto regressive. So similar concept is being applied in time series analysis also. Okay. So when you apply ARIMA model, here it is written, we use a time series past value to forecast errors or predict a future value. So they rely on the past value. The way whenever you see the auto regressive, so whenever anything depending on the past value to predict the future, it means there is a concept of auto regression. Okay, just remember that. Because if you are able to explain this auto regression somehow, they will understand that you have a deep understanding of this ARIMA model, at least this time series model, because you are predicting a future based on the some past value. Okay, so that is comes under this auto regression. Okay, so if I give you some context and then we will do some programming also. So if you see this this ARIMA model, and I mean, it's just a sequence of time series. Obviously, it's a time series model. So whenever you model any time series, so if you see your data set, let's say you are modeling in an Excel, let's say, okay. So you will see that there is a collection of points over the time. So time is one of the factor. As I already told you, this is a time interval. So whenever you are capturing a data, X will be always the time. So whenever you see anything modeled in a time series, must have an element in X, the time factor. Okay, one of the the element, one of the axis would be the time. Okay, on the Y will have some values. Okay, so we'll see that I mean in the ARIMA I'll see only one variable, that is a univariate. For example, sales, or maybe the number of passengers which are onboarding in air flights, let's say each and every year. That could be one of the possible the applications of this time series. Okay, so here linear and non-seasonal switch are great candidates for regular ARIMA models. Okay, so you'll see what is a seasonality and what is a linearity. Okay, these are the two things which we will focus on. So seasonality, and there is also a term called stationarity. Okay, this is stational. Okay, whether your the time series is stationary or not. If not, we can use a technique called differencing to transform it to stationary. And ARIMA model have the transformation covered, and then we will see how we can apply, how we can make our model stationary. If it is not, then we will transform it. Okay, so how you are going to model it, that is the more important concept. So before we model this ARIMA kind of stuff, there are a few terms which you must remember, that the seasonality component, this seasonality. Okay, so these are the few terms which will come, because whenever you model it, you'll have to face this, because if you are not answering, or if you are not able to cover this stationarity part, your model will not, the prediction accuracy would fall somewhere that you want to correct it. Okay, so it's very important. And also in time series modeling, in interview, these stationarity component will always be asked. Okay, so try to focus this, what is stationarity and when and how you want, we will make it stationary if our data is given. Okay, so this is a critical part of it. Okay, so now let's say, now we know that the time series modeling, and we have done few, the model through the data set. But now it's time to define it, because whenever you have a sequence of data points, and the data points which you are collecting over the time. So whenever you are capturing any data points, maybe let's say sales, maybe the number of passengers onboarding, maybe number of students passing in a year in a university, maybe the number of let's say the plants being planted in some desert, possibly the number of policy being given in a particular year, the number of, let's say, free funds, or maybe the different schemes. For example, the Indian government gives some kind of a schemes, each and every year they give some, the money to aged persons, okay, those who are deprived. So how much money being given to the persons in that year, okay, that you can model it through this time series analysis. Because the government decide to fund, because whenever you see the budget sessions, how they come up with the budget, projected budget, okay, this is called a projected budget for the year, let's say 24-25. So how they project it, obviously they have some kind of a data collected over the time, and based on this time series modeling, they try to predict it, that okay, in this 2025 or 2026, these are the some budgets we will be requiring based on the historical data, right? So if your data is being collected over the time, so obviously it will fall under your time series modeling, right? Now, so how looking at the data, you can say this is the time series data. Because if someday you will become, let's say, a business consultant, maybe you deal with different kind of a business problem, and let's say you're one of the client is, let's say, Ministry of, let's say, Finance, okay, and you are employed there as a business consultant, and client is asking you to model it, right? They have a data set. So you cannot apply this regression or maybe some classification algorithm. First you have to understand the data. That is more important, that what your data speaks. Because whenever you see a data and their different features, very important to understand each and every columns. If your data is in tabular format, I'm assuming your data is in tabular format, and you will see each and every column first, that what it columns talks about. Because the data understanding is more important, because business understanding comes much later, but the data understanding, whenever you will be given a data, the first and the foremost important concept is to understand each and every column first. For example, if there is something related with the financial modeling, you have to see that which all elements are relevant to you, okay? So that you have to see, and then you can suggest some of the the algorithms. Let's say if it is time series, then you'll see if there is element of time or not, the data is being captured over the time or not. If it is being captured over the time, obviously you will segregate that it's a part of time series modeling. So you'll apply only the time series modeling, okay? For example, if you are tracking anything daily, hourly, weekly weather data, that can be the one of the the clue of this time series modeling, okay? So you'll say that it is a time series modeling, okay? So for example, if you see this stock price and all that, it fluctuate over the time, okay? Hourly, sometimes it fluctuate hourly. So that is something called algorithmic trading, okay? So there the time series modeling typically applies. And also if you are able to model this algorithmic time series, you will be able to see that you will understand that how this stock price typically fluctuates, and whether you have to invest money in that or not. So That could be the possible way of applying this time series modeling. As well as there is a second example is tracking network logs. For example, if you are using AWS for deploying your any machine learning models, and you just like to see that the logs which are coming, in the every single seconds or time, okay, that you can track it that this time series that okay during peak hours how many people are using my applications and whether my application is performing well or not. That could be the possible network logs that is possible. And also in telecom industry they do have this network log that how many the congestion part, how many people are their calls are being dropped, in which time the majority of the calls are being dropped. So these are being tracked through this network logs. And economic indicators, for example this GDP and all that, that could be captured if it is captured over time. Obviously GDP is captured over times, so you can track this. So these are the part of time series data. And one unemployment rate over the the period of 10 years. For example, there is a 10 years here if you see this. So this means this is a time series modeling, right? So time series modeling will have an element of time. So here if you see there is a 10 years and also there is a 3 years, it typically indicates that it's a time series modeling. Okay, the daily stocks price, obviously it's a time series. So whenever there is an element of time in your data, it means it is a time series modeling, a part of a time series modeling. Whether you want to apply time series model or not will depend on the business use case. Okay, but at least you will have a starting point that okay I have to apply time series modeling. Okay, so there are a few components in time series modeling. Okay, so for example there is something called a trend, seasonal pattern, cycle, and how you are going to address this. Okay, so cyclic component, and there is something called a random component. Okay, so in time series you come across these kind of terms. So I mean in interview you may be asked that what is a seasonal pattern or seasonal component. Okay, so seasonality. Okay, for example during the festive seasons, few products their sales picked up, and people do get this revenue, right? So it's a seasonal because sometime you come across this seasonality. But seasonality is not always will fall for each and every business. Okay, so seasonal component will be there, but you have to see that it's a seasonal component or not. For example, in 10 years data, if you have a 10 years of a data, and in October or November, if you see there are the number of sales of some products, their sales goes higher in each and every year, it means there is some seasonal component, right? In that season there is something happening, that is why people are buying more goods. So you have to see that whether there is some festival or there is this company giving some kind of a offer during this October or November. So this is how you have to go back and check. This is called a kind of a data validations, and also check the reason. This is called a diagnostic analysis. Okay, so if you become someday this business consultant, you have to see that the reason for picking up of the sales, right, in that October or November, right? So if in each and every year if this is happening, it means there is some seasonal component, right? But there are something called a trend. So seasonal component and trend is that in some time period there is some there might be possible that you'll see that decrease in some of the sales of some of the products. So that is a trend. So seasonality and trend has a a problem, but there is something on random moment. It's not like a fixed. In seasonality it is fixed, but in trend it will not be fixed, but over the time in that trend it will show some kind of a you can say the uniform behavior, right? And trend and seasonality, that is a typical difference. Okay, so whenever there is a random component, I mean the random component is that randomly something, the sales of some products gets decreased, and possibly in some some way, in some seasons it gets higher, on a higher side, it closes on a higher side. So that is your random component, it's randomness. So if there is a random fluctuation, so at that time it's very difficult to model time series modeling, okay? Because if your data has a huge randomness, okay, huge randomness means there is a no such fixed pattern, right? So at that time, how you gonna model it? Because whenever you create any machine learning model, there should be something which your data must capture, the pattern, the usual pattern. So typically your model will capture some usual pattern with some error. But when your data has a huge, you can say, the randomness. So at that time, it's very difficult for any model, the basic model, the traditional time series model, to capture the the behavior. So in machine learning model, typically what you capture, it's just a pattern, right? It's a pattern. If you are able to model the pattern of the data, it means you are able to create some ML model. But if there is a huge randomness, then at that time, how are you going to model it? Then at that time, the huge, this deep learning model comes in, because if there is something traditional model is not capturing, at that time your deep learning model will capture it, right? Then now we will discuss, in later in the class, that profit and this LSTM, how you're going to solve the problem, the deep learning, right? Deep thinking, right? So the data of time series might be irregular, cyclic. They will have some component of trend and seasonality. If someone asks you the features of time series data, you're gonna tell them that there will be a component of seasonality, there will have a component of cyclicity, irregularity, and trend. But over the time, you have to always think in that line that time in the x-axis will always be there, right? If you see in the left side, time. But seasonality, trend, cyclicity, and irregularity is being captured over the time. That is more important. These are the features of time series model. Okay. If I have given you a data set and there is something called cyclicity. So there are some Python library through which you can find out whether it's the data which is showing you has some cyclicity or not. Is there any trend in the data or not? So these are the basic EDA, that is called exploratory data analysis, right? So you'll have some information before you model, right? So that is more important, because majority of the time, being as a data scientist, if you employed somewhere as a data scientist, your majority of our work will revolve around EDA and also the modeling, right? First, you understand the data, that how it behaves, right? So once you are able to find out the pattern of a data, that how it behaves, you will have some element that which ML model, which time series model I have to apply, right? So if you see this one, this visual, so the time series forecasting, I mean, how it looks like. If you see, the output, if you program or might have used this Python programming, so how it looks like, So if you see this one, this is your historical data. If you see, this is historical data over the time. This is a time element, and let's say it's a sales over the time up to this. This is, let's say, 2024, and in 2025, let's say this is 30 years of data. I'm just assuming 30 years of data, and this is 2025. Let's say here 2024 is this point, and this is your future predictions forecasting. Okay, for next, let's say, 20 years. Okay, next 20 years. So this is a future part, predictions part, and this is your historical data. So based on historical data, let's say this is 30 years of a data. So based on historical data, over the time, you have used, let's say, a RIMA model, and now you are able to forecast the sales for the next 30 years, right? So this is how it looks like, right? That some way there will be some fluctuation, but there might be some trend. Let's say this one, and this one is one trend, this one is one trend, this one is one trend, this one is one trend. Okay, so because it has some trend, that in some months or some year it gets dropped, but in some years it gets, the sales gets higher, closes on a higher side, right? So you have to interpret it. So looking at this graph, you are you can capture it that yes, there is some element of a trend, whether seasonality or not. You have to decompose it, okay, just to see that whether there is an element of seasonality or not. If you have a data points over the in the month, then you can easily check that in which month is there any seasonality or not, right? So you just, if I give you this kind of visuals, you can easily you just think in that line that how I can interpret it, because interpretation of a result is more important, because model you can easily do through the programming and all that, but how you are going to interpret it, that is more important, because you have to communicate it to the business, right? Because if client wants to, if client just want that just to explain me that what this graph tells, right? You cannot say that I used the Python and this is the result, right? No, you cannot say that. You have to come up with some kind of inference, some kind of analysis out of this graph, right? That yeah, over the years it is fluctuating and there is some trends in it. In, let's say, in odd years the sales gets high, but when it's even years, let's say it's getting low possibly. Or maybe in some months, let's say maybe during elections the price of some products gets lower, so the sales is higher. Maybe during not, if there is no election year in that country, then the sales may go up and down, something like that, okay, depending on the data. So if you are able to communicate that, then obviously you will be able to read each and every output. So I think interpretation of time series model is more important, and I will be explaining you the output also, that how you can read it once you have an output displayed in your screen, right? So there are models, which I have shown you, but just to understand that the few models here, we have some time series model when you have one element and one data, let's say sales over the time. Multivariate, let's say you are capturing the sales and few more variables over the time, then multivariables. So that is a possible the methods. And also the modeling part, if you come across ARIMA, SRIMA, ARCH, VAR, LSTM, but we'll see this LSTM and ARIMA, SRIMA, because this is part of a syllabus, and this one deep learning method, because deep learning technique is something that will give you a more understanding that when you have a huge randomness in the data, and when your traditional machine learning model is not working, then what is the next approach? Because ultimately, let's say if your client says that the output which are coming from the traditional model is not good, you cannot sit idle. You have to give some of the idea to the client, right? So you cannot say that the model is I have applied this this Python library, this modeling, but it is not working, so I can't help you. You cannot say that. So you have to come up with some of the deep learning model, so that, because if you are applying a deep learning model, higher chances would be that your model will give you some higher accuracy. Okay, so you'll see that how we model this ARIMA, right? So there is an element of auto-regression, and there are a few terms in ARIMA: auto-regression, moving average, and there is some differentiating method. Okay, so in ARIMA we have two models: auto-regression, auto-regressive, and moving average. Okay, so when this time series use is non-stationary, these three works together when the time series is non-stationary. In the simple words, I'm just reading it out. We call a model ARIMA model if you apply differencing at least once to make the data stationary and combine auto-regressive and moving averages to make some forecasting based on the old time series data. Okay, so as if you see, this is old time series data, this is a previous data point, and we want to forecast it. So it means it's a case of auto-regression. Okay, auto-regression is predicting, forecasting something based on old data, right? So this is auto-regression. And when we can apply, because at least you have to make the data stationary. Stationary means because we want to capture the pattern. That is why we will make our data stationary. Okay, stationary means, let's say we want to capture depth of, let's say, I'm just giving you an example. We just want to see the, capture the depth of any sea, let's say, or river, let's say. If water is fluctuating, let's say, it's coming up and down, then how you gonna see that the what is the depth of the sea, or maybe the what is the amount of the water, let's say water table, if it is fluctuating. So first we have to make the water still, then you can capture. The same way it goes, because if your data is fluctuating, then you will not see how the patterns are inside the data. So you have to make the data stationary. Yeah, the data is stationary, and then you apply this auto regression and moving average together through this differencing method. So this is just equations. Just remember that we have to make the data stationary, then you can apply this ARIMA model, this auto regression and moving average together, right? Auto regression is what? It's like a predicting something based on the old time series data, right? So how this ARIMA typically works, it's just algo and this flow chart, and I will be showing you the Python programming, that how you typically apply it. So it's a base. So there are a few terms which you will see in the output of ARIMA also. Okay, so let's say the sales time series is data. Let's say you have a sales data, okay, over let's say 30-40 years. So convert into time series object. You have to convert this time series, first time series data, because you have captured data in time series, okay, and this time series data you have to convert it into time series object first, because if you see in an Excel sheet, you will have some you can say the element of let's say sales and time together. So if you are applying Python programming, just think that you are applying a Python programming on top of the sales data over the time. So the first step would be to convert the time series object, whatever data is there, just convert it using the Python, right? And check the stationarity. So stationarity means if your model, if your data is not stationarity, I mean the data is not, I mean the still, you can say, then you will not be able to capture the pattern. So you have to make the data stationary, okay? So for that, what is the typical method we use? ADF test is there. So we'll apply this ADF test to check whether our data is stationary or not. If it is stationary, okay, if it is stationary, then you will use this differential D. If it is not, then you will increment, okay. And also there are three terms, PACF and ACF is there. I will be explaining what is that. And then there is a ARIMA, this is a function. Then if you have a P, D and Q, so P will come from this differentiation and this Q, both from differences will come. And for ARIMA model, you must have a three parameters. So D is coming from here, difference, okay, and P and Q is coming from this PACF and ACF, okay. This you have to calculate to make the model stationary, as well as the moving average and auto regression is there. So one is auto regression, moving average, and there is an element of I, that was the stationary part. So there will be the three you can say the parameters which ARIMA will take, and then it will model it, okay. And then there is a few tests, that white noise test, and then it will forecast it, okay. So you'll see that how through the programming, if you are modeling it, so you'll have to apply something called ADF test, something called P and Q should be there, ACF and PACF, okay. And in the component, this ARIMA, there are three the key you can say the parameter it takes is P, Q and D. D is a difference to make a data stationary. If it is stationary, then our work is done, because if you are making a data stationary, then you can apply this ARIMA model. That is why difference is there. If you are able to capture it, the integrative kind of stuff, you are able to model it, right? So you'll see that how we model this ARIMA. So if you see this one, P is autoregressive, okay, and Q is moving average. So we'll have an element of P is autoregressive, because autoregressive means it is a predicting a future value based on the past value. That is a PACF. And Q is your moving average. Moving average means, let's say for 4 months, each and every, let's say 12 months data is there, and you are applying 3 months of this moving average. So for let's say 3 months of a data, you are adding 3 months of a data, sales data, and divided by 3. So it will capture in Q, that is a moving average, and D is a difference to check whether your model is stationary or not, to make the model stationary. So you'll see P is the number of autoregressive term, and how many terms are being autoregressive, that is predicting a future value based on the past value. And D is the number of non-seasonal differences. Here D is your D is I, that is the difference, and P is obviously autoregressive, and Q is the number of flagged forecast errors in the prediction equations, that is Q is a moving average, right? So for example, here it is written, for example, if I give you, if I'm just giving you this ARIMA 1, 1 and 2. So how you gonna explain it, that what is this ARIMA 1, 1, 2? If someone asks you, let's say it is written ARIMA and 1, 1, 2, how you can explain it? So obviously you'll remember that AR, that is a autoregressive value, is 1, moving average value is 2, and difference is 1, right? So this is how at basic level at least you can explain, okay? So you'll see that there you see the differencing and to average moving order is applied here. So for example, let me read it out for you. For example, ARIMA 112 can also be called as a damped trend linear exponential smoothing, where we are applying one time differencing, that is a D1, on the time series if it is non-stationary, and after that we are performing auto-regression on the data with 1 log, auto-regression with 1 log, and where the series is stationary by differencing, and to average moving average order is applied, right? So you have to remember that in ARIMA, P, Q and D is there. P is auto-regressive number of terms, and Q is the forecasting error, that is moving average, and 1 is a non-seasonal differences, and that is making the your model stationary, right? So this is how you can explain this, okay? So now there are this ACF and ADF, okay? So I mean you'll follow this as I already explained that what is this ACF and PACF is there. So this is just PQ, and these are the some steps you have to follow when you apply ARIMA, right? So if I ask you that what all are the steps, you just start with the time series object, and then you apply this PACF, and also to check there is any kind of stationarity or not. That is more important, because to model it you have to check this ADF test, and just to come across that your data, if you are able to make stationary or not, then P, Q and D, only the 3 factors which you have to play with, right, to model, right? So now how you are going to apply it. So I have said you this Python, so you can run it, and let me just show you this. Let's say these are your data points, okay? So you can apply it. So let me do one thing, okay? Let's say this is a passenger data, okay? So just give me, I'm just sharing your code, so just be with me. I'm just sharing you code. Where is the code? Copy. Okay, just if you are able to just open it. I'm just giving you a minute time, just open it, and if you are able to open or not, just let me know. Deepti, just open it and just let me know if it is opening or not.
Yes, sir,
Yes, sir,
opened it.
opened it.
Okay, so okay, if it is opening, then fine, and let me just share my screen also. Okay, just to give you a context of it. So just see where is that. Okay, hope my screen is visible, right?
Yes,
Yes,
sir.
sir.
Okay, so if you see, I have used this Google Column because it gives you some kind of a intelligence to also the co-pilot kind of stuff. If you stuck somewhere, you can use it. Okay, so these are the some library that you will be using, right, for this time series modeling. So NumPy PD is basic for data manipulation and all that. As your data has this some graphs you will be plotting, so matplotlib is the basic library. The cbond, these all are the basic library that you will be using. And as the stats model is for modeling the time series modeling or any regression modeling, you will be using this. Okay, if because time series modeling is also somehow they have an element of a regression also. Okay, as I already discussed you that in Araima, if you're using Araima, so you have something called ADF test, adult fluid test, ACF, that is P and Q, that is you require. Okay, so D, P and Q, if you are using this Araima model, okay, that is why we are using. And whether there is a seasonal component or not, those, for that we are using this seasonality component. And if there is some the plot and all that, just to plot the time series. Okay, so the lag plot is there, and these are the few library that you have to understand. But for Araima, as you require this PD, for example, this you require P comma D comma Q, right? You require. That is why where from it is coming from here. Okay, I'm just removing it here. Okay, so you have to just run it. Okay, once you run it, it will execute. It should execute. Okay, and try using a Google Colab first, because whenever you're stuck in somewhere, it will give you some pop out and you'll have some co-pilot. So at least you will have understanding and explanations of the error code. That is more important, right? So let's see, it takes some time to execute. Okay, so now let me go down. Our data set is somewhere here. Okay, data set is here. So it's a on URL, it means somewhere in the internet. Okay, and we are reading because it's in CSV. You see CSV, had it been in Excel, we have to write pd.read Excel, and you are passing URL from here and parsing the data month, because if you see the data here, it's in month, so we are parsing. Okay, an index column is month, your data which is in index column, this is index column, it's in month. Okay, that is why you are using this parse. Okay, so now your CSV function, read CSV function, is taking three parameters, three values. One is URL coming from here, the data, and the month. These are the two indexing which you are passing, right? And you are displaying the first few rows. Head, you are saying head display. It means it will display the five only the five values, because whenever you are passing df.head, it is gonna print first five. Okay, if you see df.tail, it will print the last five values. Okay, and you are seeing just to see the the kind of data we want to see in a visual format, that how my data it looks like, right? That is why this is visualizations part. We are plotting using this matplotlib only. So in label you are seeing these passengers, how many passengers on the y-axis, and date will be on the x-axis. Okay, the number of passengers will display on y, and in x-axis it will display the number of the year, maybe it will display, that is when x. So in a time series model, on the x-axis we will have this time, that is the date part. Okay, and just to see, you can say for us, we are just seeing that monthly air passenger traffic, because this is a data of monthly air airline passengers. So once you just run it, if you run it, you'll have some data like this, and you'll see that how it is, how over the years the number of passengers which are on boarding, let's say, is increasing. So data starting with 1949, it was 112 passengers. So if you see over the years, the number of passengers has increased, let's say. So the number of passengers who have started using this airline has increased significantly. If you go and see in 1960s, you'll see much higher. But there is some irregularity. There is a drop also. Okay, and in some months there is an increase. So these are the trend. These are the trend. These are the trend component. And also, if you have to see within the years, is there any seasonality or not? You can see this is also one trend. So there are many trends. Okay, there are a huge trends in it. There are less randomness but huge trends. So you can your model, Arima model, can works much better here because it will capture this trend easily, right? So that is why you'll see the huge trend in it, and these trends you can easily capture it. These are the patterns basically. If any data points has the number of trends higher, it means your model will generalize it, and it will have something capability to forecast it. Because if your model is able to capture the trend, the behavior, right, so the forecasting will be much easier, right, at that time. So that you have to think. And ADF test, as already told you in the you have seen that the ADF test. Okay, so you'll see that let me just show you this. Where is the ADF test? Okay, so ADF test was there to check stationarity. Okay, we are applying ADF test. So this is the ADF function. Okay, so these are the few this is the function ADF test, and we are passing this series. Okay, and the result is ADF Fuller test, that is coming from your this ADF Fuller is coming from here, ADF Fuller. Okay, ADF test for ADF test, it is coming from there. And you are seeing this, what we are printing, the ADF stats, p value, critical value, and whether it is stationary or not. If the value is the less than 0.05, data is stationary. If it is not, then it is not stationary. Okay, so I mean as the value, if you run it, you'll see the value, p value is more than 0.05. It means it is not stationary. It means water is flowing and there is a huge current in the water. Let's say I am giving you one example, just general example. Let's say you want to see the capture the depth of river. If your water is, let's say, too fluctuating water, at that time you will be very difficult to capture it. So you have to make the data stationary here because it's a free flowing. Now if you are able to make the data still or stationary, then only you will apply this Arima model, otherwise you will not. So now you are seeing there is a huge fluctuation in the data, right? There is a huge fluctuation, right? It is not stationary, it is moving, right? So just to make the data stationary, you have to apply this. Okay, so for example, let's say if you create something like this, let's say, then it will not work. Let's say it is not displaying. Okay, so as you have to make this something like this, it should come the def, because it's sensitive. Python programming is sensitive. If you are making this like this, okay, it should work, right? It should work. Now it should work. It should come below this ADF. Okay, because this ADF is your function that you have defined, and you are passing the passengers. Okay, the series is nothing but passing the passenger their data points, and it is taking as an input. Okay, here the DF passengers. If you go and up, above up, you'll see the passengers. Okay, this data frame is passing. So what my data points is, this is all is being passing through this series, and it is converting the time series that we have seen, right? It converts into time series object, and now all the data points have passed here, and then our model starts using this ADF and all that. And once our model is giving this result, as my model is the value p value 0.05, it means our data is not stationary. And now our task would be to make the data stationary. So then the concept comes in is the difference. Then you will apply the difference at least to make the data stationary. You see this one. So now there is a diff functions to make the data stationary. You have to apply this diff function. diff is nothing but making your passenger data frame data stationary, right? This is a diff. And then we are applying ADF test again. If you see the ADF test again, we are applying by applying this diff function, that is a difference, that is a D. P, D and Q. ARIMA small bracket P, D and Q. Now we are working on D, that is a making a difference, right, on the passenger data, right? And if there is some missing value, we will drop, we will not use it. And now we are plotting that how it will looks, but here ADF will give us, because ADF test is there. So the ADF, in the ADF test, it will give us the p value also. That is why it is giving a p value. If you see this p value, okay. So if you see the value is it's not, again it's not less than 0.05, I think. Okay, so data is not stationary again. Okay, if you see data is not stationary. So we'll see that how we can also apply this to make the data stationary. Okay, so again your data is not stationary, but still you can apply, because it's more closer to 0.05. okay, then still you can apply ARIMA. Okay, if it is again not coming, okay, then still you can apply, and error will come. Okay, so now there was a something called a seasonal component that I have shown you, that how you can capture this seasonal component, whether there is a seasonal component or not. So there we can apply this seasonal, the seasonal decompose is a one function, seasonal decompose, and passing our data frame passengers. And the model which we are using is multiplicative model. There are different model also, that to see that it captures the seasonality or not, that we are decomposing it. Okay, we are further you can say making it into further analysis, that how it looks like. So we are just decomposing, means converting into different values, right? So if you'll see whether in the seasonality component is there any seasonality or not, is there any trend or not, you'll see that there is some trend, that over the years it is increasing. So there is some trend, and there is some seasonality also, right? So it is capturing the seasonality also. So just to see that the component, time series component, if your time series component t equals to trend plus seasonality is there or not. So if it is there, then it means your model will follow this time series analysis. You will be applying this ARIMA model at least, because it captures this trend plus seasonality. Trend is nothing but how whether over the time it is increasing or decreasing. There is some trend. For example, the number of employment over the years in India is increasing or decreasing. Possibly it may decrease someday, and possibly it may increase. And the number of the income of a people is increasing or decreasing, right? The income of a people, maybe the basic income of Indian people are increasing or decreasing. That will fall under this trend. Seasonality, if you see in the passenger case, the number of the people who are opting for this airplane, maybe during winter, maybe some festive seasons, is higher or not, may possibly. You'll see that how your data, because we don't know in which month people are using more aeroplanes, right? So this will follow under the seasonality, right? Okay, the seasonality. So now if I come across this one, and also there is some element of, now we have to find out the PCF and ADF, right? PCF and ADF. PCF, we are finding the PCF here. Okay, that is why we'll see once we have a difference. Once we have a difference, we are able to create a difference. Okay, we'll find out this PCF and ADF. Okay, PCF is P value, and ADF is Q value, right? So PCF and ADF we'll try to find out. It is nothing but it is more like some values. So because in ARIMA, if you remember that P, Q and D was there, so we are trying to find the three value. So D, we'll see that D, what will be the value of D, then P and then Q. Once we have the three value, we can easily model the ARIMA, right? So now we'll try to find out that the this PACF, okay, PACF value, okay. So if you apply this, it gives you something like this. In the 0, it is up, and then there are some values, and if you see this one, it is increasing. It's like a torch, something like that, and it is increasing, right? So this has some inference. I will be explaining you what is this, and where you have to stop the minimum value, what we have to take, whether we have to take some 0.5 as a P and maybe 0.7 as a P, that you will see. Okay, so these are some auto correlations, that how your data points are auto correlated. As in regression, if you remember that this auto correlations, if your model has a huge auto correlations, there are 3-4 values and they have some kind of auto correlations. Okay, so at that time, if you are not able to address this auto correlations, it means your model will be too generalized. Okay, too generalized, kind of overfitting. If you ask any unseen data to predict, and if you are using any unseen data to predict, your model will give the same answers, similar answers. So it's like a over generalization. So these are the few problems of autocorrelation. So you have to see that the how much threshold that you have to see in P value. Okay, so these are some autocorrelation. There are a few values which are partial correlation also. And let's say we are just giving a P value, let's say 2, P value 2, D equal to 1 difference, and Q is equal to 2. Okay, based on ACF and PCF analysis. Okay, so if you see the P value, we are taking a 2. Okay, 2, and this one is Q equal to 2. Okay, why we are taking, you'll see, and first we are just applying it. Okay, so if you are applying this, let's say if I'm applying this, so just see how we have modeled it. First, just see this one. Now ARIMA, as you remember, that had some values. ARIMA had P, Q and D. So ARIMA, and this will, you are passing a data frame, the data and the order, because on these passengers we have to apply this P, Q and D. Passengers is a data frame, the value, the number of passengers which are onboarding, let's say. Okay, so in this one we are passing the value P, Q and D only. Okay, but on which column we are applying this passenger, this is a data frame, because this is in time series, that is why we are converted into object. Okay, now we are fitting the model fit. So the capturing the model has the ARIMA function, and the model is storing these values, these values in the model object, and then we are fitting it using this ARIMA. Okay, ARIMA. Now once we try to print it, so whatever analysis is there, it will print in model.fit, model hyphen fit. Okay, so it will fit some kind of a report, it will generate some kind of a report, because you are saying just give me the summary which my ARIMA model is giving once I am passing the passenger data frame over P, Q and D, that is 2, 2 and 1 typically. So what my summary looks like, right? So now it is modeling, my entire data points will be modeled using this ARIMA, right? And now this is just a plot to show this summary part. This is nothing but a sophisticated way to plot, so that you can understand it. And this, there is an element of forecasting also. We are able to forecast because our model is fit here. Up to this, our model is fit means our model is we have modeled it. So it has some pattern in model underscore fit. So there is some pattern. Okay. And once we are able to capture the pattern, now I want to forecast for next 12 months, let's say. Okay. For next 12 months, I want to forecast it. So I'm just passing my steps equal to 12. I may increase it to 20. Okay. But as historical pattern is modeled in model fit, now I will forecast it. So using the forecast function and passing the month 12, you can increase also. Okay. And this is just to see the plot. Okay. So once you run it, you will have something. Okay. So now we have this model, and you'll see the plot, right? It's very important. Let me invest a couple of minutes here, because when you have this kind of output, just assume it that you are sitting in front of a client, right? Now they want to understand that what this output is telling about. What is the inference? They tell you that just explain me the inference, the business objective, and how I can apply it, right? For example, you are employed in airline company as a business analyst, and now you have an output. Let's say data scientist has given you this output, and now you are bringing this output to your client, and now it's time for you to give some of the inference to the you know uh, the client, right? How you will read it, and how you will explain it. That is more important. So you'll see that in the upper portion we have a something, just see AIC, BIC, HI, HQIC. You'll see, okay, this one. And also on the left side you have a time that when you have executed it, sample and date, and the model which you have used. Just see, the model which you have used is ARIMA, and your PQND is 2, 1 and 2, right? So I mean, you'll have in the front that you have used this ARIMA model at least. Okay. And the sample was starting from, if you see the sample, you are starting from 1949 to 1960. So at least you will have to say that, okay, I have my starting data points which was captured in the data set is 1949 and is 1960 up to this point. Okay. So, and the number of observations was 144. So now in your data points, how many samples are there? 144. Okay. And I'll explain you this also. Just see this one first. And there is a convergence time once you apply. This is more of a regression kind of thing. So these are the some coefficients of this, the features you can see. In time series, because we have only one passenger, so this gives you something like this coefficients internally when you apply this ARIMA model. And important is that you have to see that whether it is convergent or not. So it will have some kind of a hashtag here, but it is not here. Okay. So, and also there is something called this some test is there displayed at the end. So if you see this one, junk box L1, so this one is L1, and probability 0.49, heterosidicity, probability of two side. So there is something called homozygosity and heterosidicity. I mean, those people are from this econometrics. Those who have used this, maybe those who have taken econometrics, because in MBA or maybe in if you are in the business analytics course, so there is some course this econometrics is there. So there is some term called heterosidicity and homozygosity. And there is something called a Jarbe-Bera test. JB test is there. Probability JB, the probability of that JB test. Skewness and kurtosis. Skewness is kind of more of data descriptions, that how your data is, distributed over the time. Skewness is whether your data is right skewed or left skewed. For example, if there is a huge outliers in your data. For example, if you are have some age, let's say there are more young students are there in data science course. Let's say there are 80% of people who are, let's say, young, right, over 20-25 years. So it will be more skewed in the left side. It will not be skewed on the right side, because majority of your people opting for data science is having age 20 to 25 years, falling somewhere in a one quadrant. So making your data entirely skewed, right? If your, let's say, professor is planning to give some of the example, they'll try to give example related with this young people, right? They will not give something which for the mature people and all, right? So this is skewness, and there is something called kurtosis also. So these all parts of how your data looks like, and more of a descriptive. So we'll explain. So let me just pull out this one, the explanations of this, because it's very much important, because you can model it through this programming, but how you are going to interpret, that is my main aim here. So let me just help you out that how you can read this output. Okay. So now let's begin. So this is the program, and you have seen it, but when it comes to this output, right? So if you see this output here, let me web layout or something. Okay, no, it will not. Okay. So if you see this one, this is the output that we were talking about, right? So we have now this output is in front of you, and you are being asked to explain this, what it makes sense to the airline, like airline CEO. He just want to understand that, okay, this is the output, but make me understand that how I can use it for increase the how I can engage more people to come and on board my best the airline, and how I can decide different pricing of each and every flight, that what should be the minimum cost I should keep in, and when should I increase the the costing of air flight, right? So these are the few challenges he had, and now you are being asked to explain it, right? At least that how you explain it. So taking that in mind, I mean, if you see, as I already explained you, the dependent variable was the passengers. It was dependent variable because the number of times it is being, I mean, the number of people who are onboarding it is the dependent variables, okay? And the number of observations you see, that was 144. It's a small number, and obviously because it's the airline industry, so typically it is being captured over the years. So the year value will always be less. Had it been, let's say, in monthly wise in each and every year, so you'll have more data points. And the model which used is ARIMA model, right? So the ARIMA model, PKMD, which we have collected from our functions. So the AR value is 2. The model uses 2 lagged value, that is autoregressive part. You can also engage and see the predictions accuracy. So I mean, if you can tweak it, let's say if you put 3, 3 and 1, just see what value it is coming, right? So that you'll have at least a value. I mean, how typically your model performs on a forecast, because on unseen data it is more important to see that how your forecasting value gets changed when you are tweaking this ARIMA values. Let's say if you are putting 4, 1 and 4, how your output is being deviated, right? So I is integrated, that is a difference value, and to make it stationary, so you are putting 1. So I mean the difference which you are incrementing is 1, and also you can use I equal to 2 just to see that how your model behaves. So let me do one thing. Let me just experiment. If it comes, then we'll have something to. I mean, let's say if I'm putting 4, I'm assuming 4. Let's say 4, and let it be 1 and 4. Okay, and let's play with it. Okay, let's see how it works typically. Okay, you'll see that there are different, the L box is there. If you see the error part or something, there is something to if it is coming or not. Okay, so is there any error part or not, you have to see. Okay, so through this AIC and BIC, it will have a difference. Okay, so we'll see that how it typically works. Okay, and now let's say I'm just copying it, and just let me code here at the end. Okay, and making it, let me make it a 2. and 2. Okay, and then just model it. Let's see the difference first. We'll have something. Okay. Likelihood AIC, let's say AIC is 1353, if it is changing or not. AIC is 1353, so there is a difference. Okay, if you see AIC and BIC, it also tells you about the analysis and all that, so we'll see. Okay, so now just you can experiment with. Okay, and the moving average we are taking 2. So 2 lagged forecast errors. Okay, you'll see that if you can increase it. So, and there is some likelihood was there. So log likelihood function used in modeling fitting. Higher value indicate better fit. Okay, so higher value close to 0 indicate better fit. It means if you see the higher value, it is higher value but close to 0. It's a minus, means close to 0 only, right? So it's showing the better fit. AIC, alkyl information criterion, it is said. So also just try to remember these the full form of AIC and BIC, because it's very important, because people do skip this. Okay, so the R model is giving this 1353, a measure in the measure of model fit where lower values are better. It is used to compare model. A lower AIC value means a better fit. Okay, so it means if you see the lower value, it is in, if I have increased here, it was giving a lower value 1353. Okay, 1353, 1353 and 1342. Just see, it is a lower value, so it is good, right? The one which we have increased, the 4 4 and 2, is not good, right? So this is how we can iterate it, and you can increase and see the performance, right? That is why I was saying that you can capture it including this EIC and BIC. You can also write some research paper that when you increase EIC and BIC, I mean, if you are using PQ values, what effects is there on model behavior and the forecasting on ARIMA, right? The BIC is Bayesian information criterion, and our model is giving this one 1368, similar to AIC, but the strong penalty for the complexity, lower value are preferred. So the lower value, if you are using, let's say on a 10 PQ&D, if you are iterating it, and if you see the model which are capturing the lower value, you prefer that. You just say that this model is good for future forecast. Okay, so this is just a penalty. Bayesian BICs see that how much penalty is being given on the model, right? HQIC is Helen Quinn information criterion. The value which our model has given is this, and similar to AIC and BIC, but penalizes the model. Complexity is slightly different. Okay, so I mean it is kind of some kind of error, and some kind of a penalizes the model, because I mean just to check that whether if it is not generalizing, if it is not able to see that captures the patterns, then this penalization kind of a thing comes. So you see these are the important thing, giving them an idea that which model to proceed, because if you are sitting in front of a client and client is telling you that why should I go with this kind of a model, right? So you'll have something to say that okay, because the value of AIC, BIC, if AIC value is low, then you should go with this model, because the model is capturing the pattern in the model where AIC value is low, right? So you'll have something to say, because if you have some you can say the numerical values, some numbers to tell, then the client will understand that okay, that is the something, the best way to explain if you have some numbers, right? Numbers at hand, and then your explanation will be much better, right? Because you cannot say in a layman terms that okay, I mean the descriptive way that this is the reason, but if you have some numbers for the explanations, then it works well, right? And now we have something called a coefficient. So you'll see that you have seen that AR L1, AR L2, right? So what is this autoregressive term? You know that what is autoregression. So I mean the first lag one period before, and this is the first lag. The positive coefficient says that the higher previous value increases with the current value. This is how you can interpret. And this is the coefficient for second lag. The negative coefficient indicate that a higher value 2 periods is decreases the current value. So these are the some analysis that you can come across. But in the broader term, autoregressive is like that should be your model should capture this autoregressive term, because you have to predict the futures based on the past value. So for that you have to rely on this, right? That is why it is capturing the first the first previous three value, because it will capture the long dependency sometime. Okay, I will be explaining you the long dependency, and this ARIMA model it doesn't capture the long dependency, means a long sequence. That is why there comes a concept of this LSTM and profit, because it captures the long dependency. Okay, for example, in chat, this chat GPT, if you're asking the questions or summarize, if you're telling your model to summarize it document, what typically they does is they also capture the long dependency, and then they predict the next sentence, the next word. How? Because they are able to memorize it. Now if you're using ChatGPT, just try to act as a you just give a prompt that I just want to talk to you as a friend, or maybe you act as a friend to me, and then you ask chatbot a question. Just see the kind of answers they give you, because they remember each and every the past conversations with you, right? And then they give you a response. Because why? Because there is some element of memory, right? Because if your model is using a memory, it means they will be able to capture the long dependency. So in deep learning models, they have some element of memory. So whenever a model has a memory, they will be able to capture the long dependency. Okay, so I will be explaining you in LSTM and profit that how it captures long dependency, which ARIMA model doesn't capture it. Okay, and then we have some moving average. And the moving average obviously for the months and all that, and variance of residual is there, and this is more of errors. Whenever you see some errors, so how much error is there, your model is, let's say, explaining 70% of variations in the dependent variable, but there is some error. This is unexplainable, this is unexplained, right? So so higher value indicates greater variability in the data. Okay, if let's say error is too much high, it means there is a more variations in the data, and your model was not able to capture the pattern inside this uh, the variable of the data. So you have to make the data less variable. Less variables means you'll have something to see the number of patterns in the data. Let's say just giving a layman example, let's say there are 20 such patterns in some data, and your model is able to capture only 5. So it means 15 errors would be there. So that is unexplained, that is a higher side, that is a residual, right? This is one example. And we have a significance, so it's just a p-value, right? You all know that if value is less than 0.05, then it is significant. If it is not, okay. And then you have some test which we were talking about. So model diagnostic, for example, if I see this, let me go with this skewness first, because it's a simple one. So our model is giving 0.27 as a skewness, right? So a value close to 0 suggests that the residuals are almost symmetric. So if value is, let's say, 0.27, so it's more closer to 0, it means the value is symmetrical. It means in a data science course there are a equal representation of young and old people. Let's say, I'm just assuming, let's say there are 25 young people, and let's say 18 old people, let's say. So somehow it is a skewed, but still it's a symmetrical. That is why the value is 0.27. Just see that. So that is why skewness tells you the symmetry of your data points. And kurtosis here, also people may ask you what is a kurtosis. So it's a tailedness, and the three suggests are normal distributions, and it means if your skewness is closer to 0, it means kurtosis somewhere. It's a distribution of data points, the passenger data points. So it's somehow symmetrical, falls under normal distribution. So if you are given this kind of analysis or output to explain, you will have something to tell, right, on the basis of a data, because it's a data driven decisions. In the starting of the class, I talked about the data-driven decision. So how you take a decisions based on a data. Now you have something to say that, okay, my output is data-driven and my decisions, which as a consultant you are giving to the, the CEO of airline, is a data-driven. Your model is telling something, pattern, capturing pattern, and based on that, you are giving some inferences, some bullet points, so they can apply to their business to growth. And there is something called a customer experience. They can increase the customer experience based on this analysis. So I mean, it is not like the model values which you are come across, but how you can speed up the decision making. That is more important, right? And in the real world, right? So now let me come up with some of the, the a model that is, ARIMA and LSTM. Okay, so there is a two models, LSTM and profit, and let me just explain you in a couple of let me give me just 10 to 15 minutes or more. So I mean, the profit and LSTM, I mean, they are the deep learning models. So just let me just bring in some of the concept of a deep learning. So when you become a AI ML engineer, so your task would be to create a model and deploy the model as well, right? But majority of the work you will fall under this building a model and hyper tuning the model and yeah, deploying the model. But you will be working with different sophisticated model. So you will have some component of a deep learning, right? So for example, as you people belong to the business domain, so the time series analysis, because there are different organizations where their client is, I mean, there are the clients whose data are captured in a time format, right? So I come across, a year back, one of the organizations. So they were asking a people who are good in time series modeling, right? They was not interested in taking a people who are data scientists, but they were more interested in whether you have worked on time series modeling or not. So I mean, there is a specific demand for people who are very good in time series, right? Because if they know the business and all that, because there are many clients which work with the financial data, and financial data is more of the time dependent and very critical and crucial for decision making, right? It's more of a finance. So in that domain, if you want to go, so your this time series modeling should be, it should be uh, uh, you must be thorough of time series modeling. So that is why I'm just trying to explain you this profit and LSTM. So if you see this profit, so it typically calls a profit. So it was developed by Facebook. So Facebook as a organizations, now it's a Meta. So the Facebook's works on different this open source modeling, and you'll see there are different Falcon model is there for large language model, and also the llama indexing. You might have heard of a llama model, the Falcon model, and there are many more, right? And apart from the Google, it's not like a Google who are leading the this Gen AI or maybe the artificial intelligence domain, but there are different vendors and different organizations which works with these models. So the profit was, it's an old model now. It's a, I mean, the deep learning model. So it is typically used for time series data. And what it typically captures when you apply this profit, it captures the seasonality and holidays effect. So now I'm just giving you idea. For example, your client is asking you to include this holidays effect. And if you see, there are some data points. If you capture it in India, so we'll have a data which fluctuates. The sales, number of sales varies when there is some this holidays, or maybe when let's say Diwali, maybe some Durga Puja, maybe there are different festivals, let's say. Okay, so during that time people do buy more goods, maybe the buying pattern changes, right? So they do capture this holidays effect. So if your client is asking you to use a deep learning model, so you will obviously go by this profit because it is capturing holidays effect, right? It is easy to use and works well with the daily, weekly, and yearly seasonal data. And profit is particularly designed to handle missing data and large outlier in time series. Okay. So as it is a deep learning model, and just see the benefits of using this profit. It is capturing daily, weekly, and yearly. If your data points are being captured daily, weekly, and yearly, and also it will handle the missing value, because as a data scientist or data engineers, the if you go in industry, the biggest challenge is to come across this missing value, an outlier. Okay, so if your model is capturing, your worry, your problem will be solved. So at that time you can use this profit, right? So if you see these key features of a profit, and so automatic seasonality, and it captures uh, the weekly, yearly, daily seasonality, which is especially useful for a business forecasting. For example, sales and traffic. For example, government of Delhi just want to see the traffic of people, let's say in the morning or maybe in the evening, right? How much traffic it comes on the road, right? On let's say weekly or maybe daily, they just want to simulate some roads. Okay, for example, there are an area in Delhi NCR where you will find always traffic there. So if they have something, they know that the, let's say 20,000 people will walk on this road through the vehicles, so they will have some strategy at hand that okay, if there are some alternate way to navigate these traffic, then their problem will be solved, right? So they can use this profit and to see the automatic seasonality in the data, right? And as I already told you, the best I mean the best usage of profit is the holiday effects. So they capture this, and also they allows you to include holidays or special events in the model, right? So there are you will not find that this traditional ARIMA model capturing this holiday effect. They'll not allow to use this holiday effect, because obviously the country where we live in, and every month we have a holiday, right? And if you are not capturing this holiday effect or the special events, your model will not be up to the mark, and the usage is, it will be obsolete, right? So these kind of effect has significant impact on the time series data, right? So the biggest benefit of using this profit is the holiday effect and automatic seasonality, and they also allows you to capture these flexible trends, and let's say elastic growth trends. So if data is moving exponentially, right? So at that time it's very easy to use this profit, and missing an outlier value. And also, let's say if your data has a huge outlier, let's say if your data has a 20 years of a data, and let's say it's more than a lakhs of records, and there are a value which are missing. So how you gonna handle the missing and outlier value? Okay, so the irregularity is something that you have to take care of before modeling it, right? And how it works, and how profit works. If you see this profit, how it works typically. So it has a, the trend, seasonality, holiday effect. So if your data set is like that, or maybe the business case is like that, you can use it. So if you see this, how model typically looks like, so it will capture trend, seasonality plus holiday effect. So this is your Y, this is your profit. This is nothing but predictions. It will capture trend, it will capture seasonality, it will capture holiday effect, right? So this is how you can model it. Just remember that how, if someone asks you to model the profit, you will have use this trend, seasonality, and holiday effect. Okay, and the pros of using this holiday this profit is and simple to use, and it doesn't require deep expertise. And if you have a data in a time series, you can use this profit. And if you have a huge data set, and if there is some huge strong, you can say, the seasonal effect, and maybe your date, if you are capturing data weekly plus yearly both, then you can apply this. And obviously the biggest advantage of using profit is it includes holiday effects and special events, and it is useful for the business applications, and good for database with irregular interval or missing values, because in the real world or ideal case, and maybe if your value, I mean the data will not be idle, it will have irregular intervals and missing values, right? So at that time it's very difficult for people to capture it. So let me just use this if it works or not. So let me check it, the profit works or not. So let me go deep down if it is working. Profit, where is the profit? Yeah, this is the profit. Okay, so profit, if you see this one, the passenger which we are taking, this is y, and the method is monthly, data is capturing monthly, let's say. Okay, and then we are fitting the model here, fitting the model, just simple code is there, just we are fitting the model. Our model is fitted, the value is there, and now we are predicting the future value for next 12 months and monthly, right? Frequency is monthly, and this is a forecasting, we are forecasting it, the model that predict and the future. So you are passing the future, this is unseen value, and model is already model dot fit, it is fitting the value df dot profit, the data point is here, df dot profit, and the passenger value, this is the data points which are passing. Okay, and modeling, the model is fitted here, and now we are predicting the future, forecasting it, and plotting the 12 months of forecast. Okay, this is just a simple profit. So once I go down, if you go down, you'll see this kind of a, this is just a forecasting, these values are being forecasted, and this is original trend. Okay, so you'll see this is how profit works, because it also captures the irregularity, seasonal effect, and all that, it's gonna capture it. Okay, so this is how it looks like. Okay, you can run it at your end and try tweaking it. Okay, now it comes to LSTM, that is a long short-term memory. So it is very important, because in the ARIMA model, and it doesn't capture the long-term dependency. Okay, so in the interview, people are gonna ask you that what is so typical about LSTM and how it is similar or different from ARIMA, right? So why you are not using ARIMA, and when you should use ARIMA and LSTM, and how it makes two model different, and both are time series models. So why one should not go with ARIMA, right? So I mean, it's a recurrent neural network, right? So it uses a recurrent neural network, and when it comes to LSTM, they have some features of a recurrent neural network. So recurrent neural network captures this. They work on the long short-term memory, and as LSTM is more works on this time series data. Okay, and if your data points is sequential, okay, for example, if you see in chat gpt, your response which is being generated are sequential, I mean, and your training data, if you see in this case LSTM, they have a better understanding for a sequential data. If you're passing a data sequentially, for example, you try to model a language model, and if you're passing a sentence, so a sentence is in a sequence. If I'm speaking right now, I'm speaking in some sequence. So my, or maybe if you speak in some sequence, so sequence has some pattern. So LSTM has some the sequential data it takes, and it's used for a time series modeling, right? LSTM works are powerful, and for the learning this time series pattern. Okay, and what it does is, when the data has a long-term dependency, meaning past will influence the future over the time. Okay, so it is powerful. Your LSTM is powerful when your data has a long-term dependency. Okay, but earlier in the ARIMA will not have this element to understand this long-term dependency. So if someone asks you that why to use LSTM, because it's gonna capture this long-term dependency and uses this recurrent neural network, RNN, they have a feature, right? So what are the typical benefits of LSTM? Because it has a memory cells. So I mean, they can retain information over the period. Okay, they can retain the information over the period. Now, let me just explain this one. For example, ChatGPT. If you ask ChatGPT in a prompt that, you become a financial advisor to me, and now you act as a financial advisor, and now just answer me a few questions. So they're gonna behave like a financial advisor. And if you ask them that my monthly income is this one, and my expenses are this, so just suggest me some of the portfolio, and suggest me the this investment ideas. So they're gonna give you some investment idea. So if you see the responses, it starts somewhere like, as I'm acting as a financial advisor to you, I'm suggesting you, based on your data, that these policy or these portfolio you can invest, and this would be the way out to invest your money, right? So how typically they retain information over the period. What they typically does is they retain information over the period. It means they have some memory cells, they have some memory, right? Next time also you're gonna ask the similar questions. You will see that there is some dependency and the sequence of the previous answers. You will see there is connections between all these things. So how they typically does, they store the information in the memory, right? So the same way LSTM works. So they have some long dependency. They understand the previous sequence, that how data was captured over the time in the previous sequence, and the memory cells. So this makes well suited for the task which have a past value, right? And long-term effect on the present. Okay. For example, financial market, weather forecast. So if you become someday a financial analyst, at that time you have to remember this LSTM, right? And there is some forget gate, and allows LSTM to decide which information should be forgotten. So there is also a beautiful concept which are embedded is forget gate, because you cannot remember each and everything. If you are remembering each and everything, it's like capturing the huge information. You're gonna stuck somewhere. You will hallucinate, right? Just to remove this hallucination, as in case of ChatGPT, you'll come across this hallucination. So why there is a hallucination? So because they do not forget. That is the issue, right? But here in LSTM, there is a key, you can say a module which are embedded is the forget gate, that forget the information which isn't important for the modeling and all that. Okay, and it's effective, efficient at learning a relevant pattern and discard irrelevant one. So this is ideal one, right? And there is input and output gates. So LSTM networks use input and output gates to control the flow of informations in and out in a memory cells. They do not bind it. Allows the network to decide when to update the memory and when to output a prediction. So these are the key features of LSTM. Just remember that. And how LSTM works, just see. So as we have discussed, we have this three gates: input, output, and forget gate. It handles, and then in output gate they produce the future value. Okay. So when to use LSTM? If you go in the LSTM sections, let's say if you run this LSTM, and as we have seen it, this LSTM, because let me explain you this one. As this is a deep learning technique, so you will see these kind of words, sequential, dense, LSTM in the libraries, and they are using this min max the values just to make it in one scale. The value is passing the passenger in the data frame, and using this some kind of you can say the data and the scaling, and just to make it in a similar scale. And then we are modeling through this LSTM, as this is a deep learning techniques. So you'll have some input layer, the sequence, and the dense layer. These are some layers like a neural network. That is why it looks like this. Okay, sequentially, as data it takes is sequentially. You cannot pass 1960 data first and then 1949 data. No, you have to pass this sequentially data, right? Okay, and once you run it, then you just fitting the model fitting, and then you are predicting it, and this is the plotting, just to plot. If you just pass the predicting, then it will give you the one value, but we just want to see that how our model looks like over the years. Okay, So once you run it, there is some epoch. Epoch is like some kind of a scanning. So we are saying the epoch is 50. It means my model is scanning the data 50 times and then it is giving me the result, right? So this is how you can explain the epoch. If you see there, this is actual and this is a prediction one. Okay, LSTM is prediction. This one is a prediction and this is actual. So if you see that there is a less error and you just mitigate it, so you'll see that which model I should use at least. So to model it, okay, and if you compare the this LSTM and the profit, if you see their responses, there is some difference. Okay, we'll see that which model is to be used. Okay, so this is how your LSTM and profit typically works. So now just see the pros of LSTM. If you see this, the benefits of using this LSTM. So it captures the long-term dependency and trends in sequential data and sequential for complex time series data. Okay, like for example, ARIMA or profit may not work well. So when it is even your profit or ARIMA doesn't work well, you can use LSTM and can be trained on a large data set and incorporate multiple features. So for example, if you have a multiple features and there is some exogenous variables and endogenous variables. So if there are different features and time series, for example, passengers, onboarding of passengers you are capturing over the time, the number of flights it is flying over the years or something like that. If you have more features, then you can use LSTM, but LSTM is more powerful because it's a deep learning time series model, right? So that is why it has a more you can say advantage over other models. At the same time, profit has a benefits of including this holidays effect or special events in your time series model. So both have some pros, and as per the business use case, you can typically use it. Okay, at the end I'll try to show you this some of the differences that where how it is a similar different LSTM, and obviously LSTM is a deep learning model, and profit is has some deep learning technique, but more of a multiplicative model and seasonality effect. So you can say that it's an extended version of ARIMA. Okay, profit. And when it comes to seasonality, and LSTM can learn seasonality, but if your data is huge, and then at that time this LSTM will work well. And when it comes to seasonality, the profit, it automatically captures it, and that is the beautiful part of it. And it captures profit captures this holidays effect and special events, and LSTM requires annual inclusion of holidays if desired. So you have to especially design in LSTM, but in a profit it is already there. The data requirement when it comes to works well with a small to medium size. So you can assume profit as extension of ARIMA only, and okay, as it is working with small data, but LSTM will not work well with the smaller data. Requires a huge volume of data because it's a deep learning neural network model, right? And the training time is faster. So because if your client asks you that I don't have much time and I have to deploy the model, you can go with this profit because training time is faster, right? And it requires a long training time because you have seen the this epoch. If you see this epoch, let me show you the epoch. If you increase the number of epochs, it takes time. Just see, it takes time, 13 millisecond or something. But if you increase the number of epochs, it takes time. That is why this LSTM requires more time, learning time. Okay, and good for business oriented time series. It's good for the business people, and if you have some temporal dependency, time based and more features, LSTM is good. And if your data set is huge, and profit is the interpretable, you can easily interpret. It has not much of the sophisticated terms and terminology, and even the you'll have the as it is not deep learning, so you'll have values and the features which are self-explainable. And when it comes to LSTM, it's less explainable because interpretable. Reason is a black box nature of the neural network. Whenever you use any neural network, it has a black box features because it gives you the output, but you don't know how it is coming up. But profit, you know that what you have used is like ARIMA. You know that PQND, but you don't know in this PQND because you don't know, right? What PQND it has used, because they learn from the used data here and they decide which value to be given, right? So that is why at that time there is a issue of interpretability with the LSTM. So whenever you use any deep learning model, you'll come across the issue of interpretability. Okay, so run all the codes and the ARIMA that is done, and the profit and LSTM both. Okay, so you can run the code and try to see that what you feel like, and then you can also use different data sets to see that how you can use different modeling techniques in time series. Okay, so this is all from my side. Okay, so okay, so if you have any questions you can ask. Yeah, so Dipti, are you there? If you have any questions you can ask, otherwise we'll end the session. Yeah, your voice is not coming. Yeah,
It is audible now.
now it is audible, but it's coming from, it's like coming from too far. But okay, fine, just take attendance and